Hello, and today we're going to be going over the constant and constant multiple rule for derivatives. So I'm going to begin with the constant rule. And it pretty much is if f of x equals a constant c, then the derivative of that will be 0. And let's do an example. It's a pretty simple concept. So if we had f of x equal 5, then the derivative of that would equal 0. F of x were to equal 3, then the derivative of that would also equal 0. And if the derivative equals negative 700.52, then the derivative would still equal 0, just because those are all constants. And the way we can represent this graphically, say we had, let's do f of x equals 5. This is our line, and no matter what point it is, say, let's do like -2, the slope here is 0. Let's do like 7. The slope here would still equal 0. So no matter the x, it's always going to be 0. Now I'm going to go into the constant multiple rule. So if g of x were to equal c times f of x, then the derivative of that would be c times the derivative of f of x. So pretty much you just isolate the constant and then you multiply it back into whatever the derivative of f of x is. So an example of this, let's just say g of x equals f of x squared. Then the derivative of g of x would be, our constant is c, so that would be 5. So 5 times, and then the derivative of f of x, so we have n equals 2. So f prime would be 2 times x, or 2 minus 1, which would be just 1, so 2x. And then this would be 10x. Another example. Let's say g of x equals 3x cubed. Then g prime x would be, this is c, so 3 times, and the derivative of this, n equals 3. Then 3 times x to the 3 minus 1, which is 3x squared. 3x squared. And that would be 9x squared. Then our last example, let's say g of x were to equal 1/2 x squared. This is our constant, n equals 2, so it'd be 2x. So g prime x would be 1/2 times 2x. That would just be x. Thank you for watching, and I hope this helped.